Alright, let's continue. Anyways, so now we have this, x cubed, and the derivative of everything, so on, right? C to the n, x to the n, right? Right? How do we solve this? Right? This is x, right? Does this really apply to x to the n minus 1? This is x, right? Does it really apply to x to the n minus 1? Well, this can also be rewritten as x to the power of 1, right? So if we're finding the derivative of that, also, by the way, when you're multiplying a function by a constant, the derivative is that by the constant. When you have x to the 1, right? When a constant's alone, then, right? I already showed you why. You always multiply by the constant, and the reason why you find the derivative of a constant is equal to 0 is whatever. X to the 1, right? So what would you do? Well, this is x to the 1, right? So now we can do x to the 1 minus 1 times 1, which is equal to just 1, right? Bada bing, bada boom. I bought the room. E to the x is equal to, now this whole thing can be rewritten as e to the x is equal to c, right, plus 2c2x plus, right, you apply the same thing to each one, and you get 3c3x squared plus so on to the x power derivative plus, n minus 1 times x to the n minus 1, or just n, n x to the n minus 1, right? That's our new equation, right? That's our new equation. So we just found the derivative of that, right? But the thing about a derivative, it's the slope of a line. So of any point on the line. So at a point, right? At a point, if you evaluate the derivative at a point of 0, right, say, it has to touch that same point like e to the x, right? We also find the derivative of e to the x, and that's just e to the x, right? The derivative, we already established, derivative e to the x is equal to e to the x, right? So now we have this equation. How do we cancel out the x's? What we did before, we just make x is equal to 0, and that is 1 is equal to c1. So we add 1, right? We add 1 to this newly formed equation, and it is beautiful. Now we gotta finish the rest, right? And you may be saying, oh, so it's just 1. No, it's not, because we need to find the second constant, right? And there's a difference, right? So how do we find this if we already found the derivative, right? Well, we can find the derivative again. If we continue doing this, this is always going to be e to the x. This is always going to be c to the 1 plus 2c to the x, right? So it always works, and you find the constant, right? So now, if we find the derivative of this whole thing, right, this is getting way too dark. If we find the derivative, much better, of the whole thing, again, right? Right? Find the derivative of this whole thing, well, a constant's going to cancel out, right? This constant will cancel out, right? So this is 2c2 times x, right? Plus 3c3x squared, and so on, right? Well, if we find the derivative again, we use the power rule, and e to the x is just equal to 2 times a constant of 2 plus 6c3x, and so on, right? So now we just do the same thing. We get 1, right? We get e to the 0 is equal to all of that, cancel that out, and that is equal to e to the 0 is equal to 2c2, right? So we have 1 is equal to 2c2, not 1 is equal to 2. 1 is equal to 2c2, and we solve for c2. 1 over 2 is equal to c2. So now we plug this in and we get 1 plus 1x plus 1 over 2x squared. So now we know that we're actually making progress, right? Let's remove this big ass 1 and just put x with a blue marker. Those x, right? And if we continue doing this forever, infinitely, right? We do this for the third one, right? I'm not going to waste my time on that, or on all of them. The third one, I know you're begging to know what the third one is. Well, the third one is equal to 1 over 6, right? Well, if you continue to do this infinitely, you notice a pattern, right? And you notice that e to the x is equal to 1 plus x squared over 2 plus x to the cubed over 6, right? Plus x to the 4 over 24 plus x to the 5 over 120. I'm not memorizing this, I'm doing the factorials. If you memorize things, you're an idiot. No, just kidding, I love you, but you probably shouldn't memorize it because that is a horrible way to do things. Plus x squared 720, pretty sure that's 720, so on. Plus whatever, x to the n times some constant, right? Yeah, that's what e to the x is equal to. And if you notice one thing, well, I haven't told you what a factorial. My bad. Another thing to know: a factorial of a constant is equal to that constant, and you multiply it continuously until you get to 1. So 4 factorial is equal to 4 times 3, which is 12. 12 times 2 is 24. 24 times 1 is equal to 24. 1 factorial is equal to 1 times 1. 2 factorial is equal to 2 times 1, which is 2. 3 factorial is equal to 6. So on. And another property that I need to tell you real quick so you don't get confused. 0 factorial is equal to 1. I want you to know that that may baffle you for a second, but using calculus, and I don't want to get into it because that requires a lot of calculus. That's multivariable calculus. That's calculus 3. And you can also use number files video. Just go to number files video about why 0 factorial is equal to 1. So yeah, 0 factorial is equal to 1, right? So we know all these properties. Well, this kind of looks like 1 plus x plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. That looks peculiar, right? So can't we just put this for, sanity? This can be written as e to the x is equal to 1 over 0 factorial, since this is 1, plus x over 1 factorial plus x squared over 2 factorial plus x to the cubed over 3 factorial plus x to the 4th over 4 factorial, and so on. So on, right? And that's the definition of Taylor series. You can continue doing this with any series. A circle will work, and it looks beautiful. Kind of spoons the function, right? A circle will work for half of it, though, since it's, again, not continuous, kind of. Right, so there's kind of a pattern here, right? This is equal to x to the 0, this is equal to x to 1. So it's increasing by 1 to x squared to x to 3. So it starts from 0, we can say. So this starts from some thing starts from 0. And it's doing the same thing as we approach that, right? And this is adding, so we can call it a sum, right? And if we do this infinitely, then it's the most accurate we can get of x to the n over n factorial, which is equal to e to the x. That is beautiful. This also helps us realize the similarities between factorials. Helps us like with 1/2 factorial. Yeah, that's crazy. Negative 1/2 factorial, negative fucking nigger factorial, right? Negative 1135 over 1/6 over pi. Over pi factorial, right? This helps us do that, and that may seem ridiculous, but it is possible using calculus. I'm teaching you calculus, but I'm not going to go that far, right? We're just trying to find e to the pi I. Why is that equal to -1? And a lot of calculus teachers on YouTube apparently have a difficult time explaining it to the public scheme, this public scape, which is most interested in it. It's amazing. 2.781 to the power of 3.14 times square root of -1. What is this mess, and how is this equal to -1? This is insane, right? It's insane. It would seem insane, right? So obviously there's a lot of people that watch it. You know, a lot of people who have no idea what calculus is, they watch it, you know? And many people suck at explaining it, and they expect, you know, great things, and they really suck at, you know, doing it. I'm not saying I'm the best, but I'm just saying I've noticed that I'm gonna try my best, but, you know, I can't provide. So like I said, we could do this with any function, especially trig functions. Right? What are trigonometry functions? What is trigonometry? Say we have a triangle. So we have a 90-degree triangle, and we have a hypotenuse of 5. One side length is 3, and one side length is 4. Right? This is that angle. Say we have any angle, right? Angle x, right? What is sine of x exactly? Sine of x